It's November the 12th, 2020, and welcome to the Water Action Platform. This platform is dedicated to collaboration and knowledge sharing within the water sector. It's open to all, free at the point of use, and is made possible by these wonderful sponsors. I thank them all. This week, alongside the usual COVID-19 updates, we have a special focus on the circular economy. We have a sector expert interview with the head of innovation at Severn Trent Water, and not one, not two, but 3 short technology showcases. There were so many good ones to choose from, I quite simply couldn't just choose one. Now, regular viewers will recall that we often start with an infographic, and you might remember this one, which we shared in April 2020. It was produced by the University of Minnesota and outlined the 3 possible scenarios for how the COVID-19 outbreak might develop. Was it going to be scenario 1, wave after wave of similar outbreak peaks? Or scenario 2, where the big peak was yet to come? Or scenario 3, with the April peak being the big one, but life getting easier thereafter? Now, at the time we shared this image, most of us were just going into the first peak, and I received various angry comments from people telling me that it was irresponsible to share such pessimistic predictions. Sadly, it is scenario 2, which appears to be playing out in many parts of the world. But with the positive news earlier this week regarding a potential vaccine, hopefully these scenarios will now change for the better. Now, another infographic that we shared a few months ago was this one from the World Economic Forum, which highlighted all the risks and downsides to the pandemic. It identified prolonged global recession, bankruptcies, and high unemployment as the highest risk items. A number of you asked us to produce a new infographic highlighting the potential benefits from COVID-19. Now, without wanting to trivialize just how awful this pandemic is, there are some upsides. And if we now really do have a vaccine on the way, it will be important that we capture those benefits. So, we identified 20 potential benefits and ran a survey within Isle. The results are presented here, with better hygiene practices, better air quality, and a faster move to digitisation coming out on the top. Interestingly, a senior executive at an Australian water utility shared with us that he felt underwhelmed at the scale of change that the utilities were doing. He suggested that we conducted a survey across the Water Action Platform community to identify the initiatives which are being planned for a post-COVID-19 world. If you think this would be of interest, let me know, and we will organise it. Now, before we dive into the circular economy section, let's have a quick look at what's happened over the last few weeks with COVID-19 and wastewater-based epidemiology. And we start with this reference from the good folk at CDC in the USA. The CDC have updated their website with key data on sampling strategies, testing methodologies, communication protocols, and the like. It is a goldmine of information. It even includes targeted use case studies, including helpful information on how to do wastewater surveillance at specific facilities, universities, correctional facilities, food processing sites. The CDC website also includes helpful information on what peer utilities are doing. If you are a water utility considering adopting WBE, then I recommend that this is a good place to start. Similarly, you might recall we interviewed the chief executive of Luminultra back in July. He shared with us what they were doing with regard to SARS-CoV-2 wastewater surveillance. Well, I'm pleased to report that their work has continued to be successful, and they now have a simpler, faster, and cheaper process for wastewater monitoring. As with the CDC website, if you are a water utility considering adopting wastewater-based epidemiology, then I encourage you to connect with Arthur at Luminultra to hear how they might be able to help you. Now, we have known for months that we can use WBE to get a 6 to 8 day early warning of a COVID-19 outbreak. We've reported on it here multiple times. Somewhat incredibly, researchers now think that that window could be increased to 16 days. How? Well, it's not through wastewater-based epidemiology. A recent study published in the Mayo Clinic Proceedings shows that analysing Google web searches for keywords can help predict the spread of the disease. The research was carried out across 50 states in the USA and analysed the occurrence of just 10 keywords. The top 3 were face mask, Lysol, and COVID stimulus check. These 3 words had the strongest correlations with peaks being seen up to 16 days prior to the first reported cases. So, WBE gives us a 7 to 10 day warning of a COVID-19 outbreak, but Google potentially gives us 2 weeks. Of course, using both together would perhaps give us the best, cheapest, least intrusive early predictor yet. Now, our next paper, when it was presented to me by our resident WBE expert, Dr. Jo Burgess, it got her hugely excited. To quote her directly, it got her inner geek doing backflips. Why? Well, because it's proper new news. It is forefront science. 16 researchers from a variety of research institutes in universities in Italy have, for the first time that we know of, successfully assessed the viral load of RNA and this is the important new bit, the amount of infectious SARS-CoV-2 virions in water. The presence of SARS-CoV-2 in raw wastewater has been demonstrated in many countries many times, but the RNA does not indicate that the infective virions are present. The virus presence and infectivity in wastewaters has been poorly investigated to date. Now, in this study, multiple samples were analysed. The isolated virus genome was sequenced and found to belong to the strain that most spread across Europe. Importantly, the virus infectivity was always null, indicating natural decay in the virus pathogenicity. Samples from receiving rivers showed in some cases a positivity, probably due to non-treated discharges or CSOs, but nevertheless the river infectivity was null. I asked Jo what this meant. Does this mean we can now go wild swimming in rivers without any fear of catching the virus? The short answer is yes, apart from all the risks that are associated with other waterborne viruses. Of course, this is preliminary data, and should you feel minded to jump in your nearest river, we encourage a precautionary approach to your risk assessment. Next, we have this paper from our friends at the Dubai Police, who have, perhaps surprisingly, been long-standing members of the Water Action Platform. Now, recently an article was published which stated, wrongly we believe, that air travel is safer than going supermarket shopping with regards to COVID-19 transmission. The article was authored by researchers at, and get this, the Aerospace Medical Association, the International Airline Medical Association, and the International Air Transport Association, organisations which arguably have a vested interest to get us back onto aeroplanes. Their paper has been negatively critiqued by numerous scientists. The article is countered by this paper, where researchers tested almost 3,000 municipal wastewater samples and 200 commercial aircraft wastewater samples. They tested wastewater on commercial flights arriving from Dubai from 59 destinations across all 6 continents. Fascinatingly, almost 14% of the samples tested positive. Now, this is despite the fact that to board a flight to Dubai, you have to have had a negative nasal swab result issued within 96 hours prior to you travelling. What this paper shows is that data from aircraft wastewater monitoring could be an incredibly useful tool in controlling the outbreak. If the data from multiple airports was accumulated and shared widely, it would help decision makers in any country make informed decisions about which countries should and should not have travel bans. Once again, we see wastewater-based epidemiology having a real live application. So now we come to our sector expert, and this week we have a focus on the circular economy. What is the circular economy? Well, to quote the Ellen MacArthur Foundation, a circular economy entails gradually decoupling economic activity from the consumption of finite resources and designing waste out of the system. Here to explain their approach to embracing this important topic is Richard Walwyn from Severn Trent Water.
Hi, I'm Rich Walwyn and I'm Head of Asset Intelligence and Innovation at Severn Trent. So over the next few minutes, I'm going to share with you some of the things that we're doing at Severn Trent in transitioning towards a circular economy in water. At Severn Trent, we believe that transitioning to a circular economy in water is an essential ingredient in our ability to meet the supply and demand challenges that we're going to face over the next 20 to 30 years. In addition, we believe that there are significant opportunities to maximise value for our customers through the recovery of some of the byproducts of our processes, as we've done in recent years in anaerobic digestion and renewable energy production. Historically, our innovation approach has been to spot specific opportunities through our research that we've tested and if the business case stacks up, scale. And this has resulted in some utterly brilliant successes. For example, in the last 5 years, our innovation has resulted in the construction of substantial new thermal hydrolysis process assets at our Minworth and Strongford sites, which use anaerobic digestion to convert sewage sludge and trade waste by anaerobic digestion to produce a stabilised sludge product and biogas. Now, whilst this spot point approach to innovation has served us well, the triple threat of water scarcity, rising energy prices and climate change are driving us to be more holistic and targeted in our approach. So we've created 3 pillars to our new innovation framework. They are protecting the business, ensuring that we're helping our business to solve problems and to deliver against the performance and financial commitments that we've made. Secondly, enabling outperformance, so creating the opportunities to outperform against those commitments. And these are new technologies and ways of working that we're identifying through our extensive ecosystem that drive incremental value into our organisation. And finally, transitioning to circularity, identifying solutions that realise the opportunities that a move to the circular economy will bring for our customers, colleagues and shareholders. So to help us to prioritise these opportunities and to articulate what they are and why they matter, we've chosen to align the circular economy pillar of our innovation framework to the 3 circular economy transition pathways that have been developed by the International Water Association. These pathways are the water pathway, focused on minimising the waste and losses from our processes and exploring reuse, recycling and replacement of water with our customers. The materials pathway, focused on accelerating opportunities to recover nutrients and other byproducts of our treatment processes. And the energy pathway, focused on maximising recovering the embedded energy and delivering upon our science-based target commitments. Now, we started to create a structured plan by firstly understanding the opportunities that exist for us in each of those pathways in our end-to-end value chain, and then assessing each opportunity based upon its net value to our business and also how advanced the potential technology solutions are and what needs to be true to boost them. This involves identifying new technology-enabled business models and ways of working that reduce value loss through recycling, reuse and replacement of water, maximising the recovery of materials from our processes, minimising energy consumption and process emissions, and maximising the production of green energy. We found that the pathways also provide more clarity on what regulatory and market levers exist to help us to drive up value, forming a simple way for us to frame the support that we need from our regulators and from government. Now, it's also clear that forming effective collaborative relationships and partnerships is key to maximising the opportunities that a transition to the circular economy brings. So I recognise that some of you will already be advanced in your circular economy journeys, and some of you will perhaps be just starting out. So irrespective of your circular economy maturity, we're really keen to explore opportunities to work with like-minded organisations on identifying and developing cross-sector solutions and also accelerating our plans. So to close, I have a few questions I'd like to pose to this group, and if you are interested in further discussions, I would really love to hear from you. So the first question is, are you considering the circular economy in the development of your business and your innovation strategies? The second question is, are your board committed to transitioning towards the circular economy? Thirdly, are you prepared to share some of the activities that you're pursuing relating to the circular economy? And finally, are there any initiatives that would benefit from partnership working in your portfolio? Thank you.
Thank you, Richard. Now that provides a wonderful introduction to our next section, the technology showcases. And this week, we have 3 separate technologies to whet your appetite. They cover nutrient removal, energy production, and cellulose recovery. So let's start with Ostara. Based out of Vancouver, Ostara has arguably led the way in pioneering phosphorus recovery from sewage sludges. And here's Matt Kuzma sharing details on what they do and how they do it.
Today, we're going to talk for just a few minutes about phosphorus. If you ask a water manager, regulator, they'll describe phosphorus as pollution. And as a result, we spend a significant amount of money every year preventing phosphorus discharge into water bodies where we don't want it, as it causes eutrophication, algae blooms, and other negative impacts. But at Ostara, we view phosphorus a bit differently, and we really view it as a mismanaged resource. We're looking to capture that phosphorus from water discharges and try to recover that with valuable nutrients as a sustainable, eco-friendly mineral fertilizer product. If you speak with a horticulturalist, livestock manager, or farmer, and you ask them about phosphorus, they view it as a resource, as an ingredient necessary to support our global food production. And to meet this demand, annually we mine millions of tons of phosphate rock, a finite resource, to feed our growing population. But Ostara solutions provide a unique opportunity to recover the phosphorus from water bodies where we don't want it, and to use it as a resource in a high purity fertilizer product that can be placed directly back into the fertilizer value chain, reducing demand for phosphate rock, but also preventing phosphorus pollution on the non-point discharges, because it's not water soluble and thus reduces the runoff and leachate from fertilizer application into fields. So it's a true win-win, addressing both point source and non-point sources of nutrient pollution. To do this, we remove phosphorus from wastewater streams using a patented upflow fluidized bed reactor, branded as Pearl, and producing a high purity fertilizer granule, branded as Crystal Green. It's greater than 99.6% pure as a crystal. And we do this process cost effectively in comparison to traditional chemical removal processes that are used to address the same phosphorus discharge challenges. Even better, part of the overall economics is revenue return from the fertilizer sale that helps offset the operational and capital investment costs required to make the project work. Even though it comes from a wastewater source, ironically, crystal green fertilizer is a better fertilizer. It's higher purity, lower salt index than traditional fertilizers that you buy off the shelf, and has low water solubility. As I mentioned, it reduces leaching and runoff. It's 90% reduction in energy to produce. This is a US EPA study looking at embedded energy that's required to produce fertilizer. Crystal green from wastewater uses only 10% of the energy required to produce conventional mono and diammonium fertilizer, phosphate fertilizer products. There's no pathogens or other biological contaminants. As you can see, it's a white crystal. And again, it's addressing both non-point source and point source discharges. So you get more crop yield with less pollution, making it the true win-win. At Ostara, we're proud to be part of this new circular economy, offering solutions for fertilizer production and phosphorus management in our water sources that brings value to both industries. Nothing demonstrates resource recovery more accurately than removal of phosphorus from water streams where we don't want it, to avoid eutrophication, and putting a better fertilizer off into our fields with improved food yields and non-point source pollution reductions.
Thank you, Matt. Now, Ostara have numerous full-scale facilities around the world, and as Matt mentioned, they have this particularly interesting commercial model in where they buy the P-rich crystal green product that the water utility produces. Now, this approach dramatically reduces the commercial risk model for the water utilities, who, perhaps not surprisingly, are somewhat reticent usually to enter into the market of selling fertilizers. Now, our second technology showcase is from Electrochaea. Based in the US and in Germany, Electrochaea have developed a power-to-gas energy storage concept. Now, in simple terms, what they do is they convert renewable electrical energy into chemical energy in the form of methane. By converting water into hydrogen and oxygen through electrolysis, they can enrich raw biogas. So here is the CTO and MD, Dr. Doris Hafelbrunn, to share some more details.
Our technology is fairly simple actually. We are using typically an electrolyzer off the shelf that uses renewable power, generating hydrogen as well as oxygen and heat. And we use the hydrogen to feed our biocatalyst, which belong to the domain of archaea. This needs to be combined with CO2, can be raw biogas, can be another CO2 source. And these archaea that are inside this little reactor here, they are then producing highly pure methane and also heat. What's unique about our technology is our unique biocatalyst. It's a patented strain and is very much optimized to generate a lot more methane and do it more efficiently than other strains do it. How does the plant actually look like? Here's the schematic. You see here on this side the electrolyzer that uses the electricity and clean water, splits it into hydrogen and oxygen. And then we need the CO2 source or a biogas source would also do. We compress that CO2 and then it goes into our bioreactor, which is a long column to have a bit of time to actually start here with the gas introduction and to turn all the gases into methane, which comes out at the top end here of the reactor. And it goes through a membrane system to take out all the hydrogen that is still maybe in the product gas and to recycle it back into the process, because that's the highly valuable component of the system and also the most expensive one. The biomethane that we are generating here can then be injected directly into the gas grid, and that's our storage facility. 1 megawatt electrical power generates 200 normal cubic meters per hour of hydrogen. That needs to be paired with 50 normal cubic meters per hour of CO2 or a biogas that contains this amount of CO2. And we can then generate 50 normal cubic meters per hour of methane and 320 kilowatts of heat that then, and the biomethane is then injected directly into the grid.
Thank you, Doris. Now, at the risk of stating the obvious, the oxygen that's generated during the first electrolysis step can also be used to enhance the secondary treatment plant of the wastewater site, pure oxygen making the bugs work that little bit harder. Also, the biomethanation process is exothermic, meaning that it generates heat, and that heat can be used to heat the sludge before digestion. We now come to our third showcase, and it's a technology that has the glorious name of Cellvation. I just bet the marketing people had fun with that. Now, Cellvation recovers cellulose from sewage. The cellulose comes from toilet paper originally, and the recovered cellulose fibers are sterilized, dried, and made into pelleted or wool-like products, collectively branded Recell. Here is Koos Vessels, Technical Director of Cellvation, to share some more details.
What you see here is an overview of consumption of tissue paper, and it's not all ending up in the sewage, but it's quite a lot. If you look in these countries, in the European countries, we're talking about 6.6 million tons of tissue that is sold. And if you look in the Netherlands, then approximately 70% of what is sold ends up in the sewage system. If you would project that on the European scale, so on all the countries that you see here, we're talking about 4.4 million tons of toilet paper coming into sewage systems. The Dutch Water Authority around Amsterdam, they start to look in harvesting material up front of the treatment works, in removal of solids from wastewater. And that's where we picked up as well. We started with fine screens, doing research on what's happening, how you can reduce energy in your treatment plant by harvesting solids from it. An overview of the process stages. Once you have these cellulosic screenings, we remove the grit out of it. We wash the cellulose. If you take it from your raw sewage, you will see that there's seeds in it, there's hairs in it, there are parts of plastics, there's everything in it. And we take it out in a process that we did build ourselves, in a cellulose washer. We again take out the fibers from the watery stream. We dewater it first up to about 50% of dry solids, then dry it off to about 98% as a sellable product. Then the materials that we get from it, this is what you see coming into your treatment plant, coming from the core screening. If you have grit removal, you have something. Then we get a material, I call it here a drum material, or drum material that's coming from a cellulose washer. It's the residuals from it. And we have resell as a product. This is something that we really sell right now. Here we are working on the development of making something again out of it as a resource that we can value. Otherwise you should put it right now in a digester or something, but it has value still, so you can make products out of it. The first application, a lot of this material went first stage in asphalt with the thanks to the water board of Friesland. They started to develop it together with the province there, and it developed a market. Cellulose is an additive in asphalt I would say to keep it stable once it's still warm. And the first cycling path worldwide with cellulose-based asphalt from sewage was here in Friesland.
Isn't that great? A cycle path made from recycled, used toilet paper. 3 great circular economy technologies. If you want more details, please follow the links or let me know and I'll introduce you. Those technologies all came from our technology approval group process, which, if you're not already involved with, you are welcome to join. I should stress that we could have easily done so many more interviews and technology showcases. There is so much circular economy experience and learning right to be shared. For example, time did not allow us to include it in this broadcast, but here is a link to Henry Romain, Director of Environmental Services and Technology in South Africa. And one can't talk about the circular economy without mentioning Frank Rogala, Head of Innovation at Aqualia. Frank has been involved in multiple groundbreaking collaborative circular economy projects, some of which have been highlighted in the recent Netflix film Brave Blue World. If you've not seen it yet, it's well worth checking out. And finally, we come to this truly wonderful story which shows that those with poor eyesight might actually have an edge over those with 20/20 vision. Researchers at 3 university hospitals in China noticed that very few COVID-19 inpatients wore spectacles. Of the 276 patients hospitalized in Xuzhou, China in January to March, only 6% had glasses, much lower than the 32% in the local general population. They collected data from across the Hubei province and found that people with myopia who wore spectacles all day long, i.e. for more than 8 hours per day, not just putting them on to read, they may be less likely to catch COVID-19. Now, this finding is actually consistent with what we know about how SARS-CoV-2 can enter our bodies via the eyes, nose and mouth. Covering your nose and mouth with a mask and your eyes with sunglasses or spectacles is likely to decrease your exposure and therefore your risk to COVID-19. Now, this of course is just one study of under 300 people early in the pandemic when social distancing wasn't being recommended and there is no data on hand hygiene. A more purposeful study going back into the records is needed before drawing firm conclusions. However, if you are looking for an excuse to wear your cool-looking shades during winter, you now have it. Now, just before we finish, here is an event you might want to put in your diary. It is a virtual 3D tour of AGEA's new wastewater treatment facility in Brazil. During the tour, AGEA will outline in particular the advantages of the BIM design methodology and the digital twin technology which they have developed. The tour is scheduled for December the 15th at 2 p.m. and 10 p.m. GMT, 2 separate tours to cover the wide differences of the Water Action Platform members. You don't have to have 3D glasses, but I am reliably told that if you do, it's a much more immersive experience. If you want to be part of this, let me know and I will add you to the calendar invite. Once again, I thank our sponsors for their support. I hope you enjoyed having a circular economy focus this week. Next month, we're considering having a special focus on leakage and non-revenue water. With that, I bring this broadcast to a close. See you next month, Thursday, December the 10th. If you've registered at wateractionplatform.com, then you will get a calendar invite shortly from Megan. My name's Piers Clark. I'm the chairman of the Isle Group. Keep asking questions, keep sharing, and keep safe.